Once we spark the gas and it lights up, it gets up to about 17,000 degrees Fahrenheit. So, yeah, nothing really can stand that heat. So that's kind of why it's got that electromagnetic field. And also, the second part of that is the sample comes through this little spray, and it sprays and it aerosols it, and then it gets pushed into the plasma. And once it gets in the plasma, it just starts breaking apart so that we can get individual atoms. And once the individual atoms are separated out of their molecules and things like that, then the electrons, they excite the atom, and then the atom emits a wavelength of energy, which comes out in the form of light. I don't know, there's a little thing over there that shows wavelengths, yeah. And every element has a specific amount of energy that it emits when it gets excited. So then there's these detectors that, in this instrument, that they sort out in 3 dimensions, like all the different wavelengths that are coming out, and then there's little chips, and then the chips come to the computer, and then we get a little graph like that, and then it shows where it's reading it, and it gives you concentration. So the intensity of the light is what tells us how much of that element is in the sample. So it's kind of a cool instrument. It's fast too. It's amazing. This is light. So you're running the sample. As soon as the sample gets in there, boom, it's there. So the only problem is sometimes it takes a long time to get the plasma going.
So how do you calibrate this machine?
We calibrate it. There's all sorts of mirrors and things, because the mirrors separate out all the light. So there's this calibration buttons you put on there, like you know, the mirrors, and you make sure everything's reading the way it's supposed to read. And then depending on what type of element we're looking for, we have a range where a sample should fall into a certain range. And so we have maybe like 0.51 to ppm of a sample, and then it should give us those results out. So we know exactly how much of the element it should be reading. So we make sure all the standards come out where they're supposed to be, and that they make that nice calibration curve, and then we're ready to go.
So you have like a solution that's got all the specific elements that you know what they are first.
Yep, they're all right behind you down here.
Okay.
And we have to measure them out with these, they're very specific. We have we need 1 milliliter of whatever, and we have precise little pipettes and things like that to make sure they're exact. Acid rinsing everything, washing everything, because stuff gets contaminated like crazy. So, and then your standards get messed up, and then you got to start over. So yeah, you got to be really careful with that. So we have this instrument, and we have so many carbon projects. We need to know carbon, and we need to know hydrogen and nitrogen. Those are all things that are in the atmosphere a lot. So this thing just does carbon, hydrogen, nitrogen. It's called the CHN, the True Spec CHN, for carbon, hydrogen, and nitrogen. And what this thing does is you put a little sample in there, and it drops in, and it completely combusts. But before it does that, it purges all the atmospheric air out of it. Nothing, because carbon dioxide in the air, and tons of nitrogen in the air, and moisture. So you got water, you got all sorts of things in the air that we breathe that contaminate. It's a spectrometer, but it only looks for these elements, so it's a little less high tech. That one will look for all those other elements, but this one just looks at CHN, so it's only looking at those wavelengths. So the computer is a little less complicated. We also use this for feed analysis too, because you get the protein from feed from the nitrogen amount. So we're running lots of plant tissue, animal feed.
So I'm assuming this one's a lot easier to calibrate?
Yeah, it's good, but sometimes it takes a while to get it going, because it's purging all the air out of it. So we got to run tons of blanks. And this is a lot slower too, because it's combusting and then cleaning everything, and then going from, it has like all these little catalyst tubes it goes through where it's cleaning out the nitrogen, so it can account for the carbon, and cleaning out the I think it does carbon, and then it does hydrogen, and then it goes through and purges through everything out, and then it gets to nitrogen. So it takes about 4 minutes per sample for the feed, and then like 6 minutes for soil. I think it's about 850 degrees Fahrenheit. and I got to go in there and change this crucible out all the time, and it's 850 degrees, and it's hot, and I take it out and I put it in this thing, but you can't have this can touching anything because like stuff catches on fire if it's anywhere near that can with this little piece of this little crucible in it, but it's glowing red hot. And then these will give you the total amount. So that's sometimes it's not good for agriculture, for soil, because with soil so complicated and with how plants use soil that they want to know available, where this is like total, where stuff's breaking down and it takes years and years and years for stuff to break down for these things to become available. So it is an auto analyzer, and it uses a colorimeter, which has these little colored discs in it, and then we get ammonia and nitrate, available ammonia and nitrate from this instrument. And the way that it works is there's ammonia side and nitrate side, and it goes through these catalyst tubes and things. Depending on how much ammonia and nitrate, there's a chemical that binds with those and changes color. And so they're going through these tubes, and there's little air pockets in between each of the samples, and they're spinning through, and then they go through the catalyst, they change colors, they go into the colorimeter, and the colorimeter measures the intensity of the color. It comes out on this little graph here in peaks, and then we read the peaks, and we calibrate it, we do our standards, we're reading the sample peaks, and then see how much nitrate and ammonia are available in that soil.